Hey, what's up, Long Branch? Today we're going to be moving on to Chapter 6. And Chapter 6.1 is on relations and functions. This is going to be a little bit of a review to us because we've been working with linear equations. Now we're just going to talk about them as functions. So let's go. Started off, our key idea is ordered pairs can be used to show inputs and outputs. Okay, this should be really familiar to us. Our inputs are like our x from linear equations, and our outputs, hang on, let's make this red, okay, are like our y's from linear equations. Except now we won't be using them as linear equations, more as just describing what kind of relationship it is. So our inputs and our outputs can be written as an ordered pair. The key idea says a relation pairs inputs with outputs. A relation can be represented by ordered pairs or a mapping diagram. So we should be very used to our ordered pairs. If this is our x, we put it into a function and we get this is our y. A mapping diagram does the same thing, it's just more visual. We see where each one goes. If we plug in a 0, we get 1. If we plug in a 1, we get a 2. And if we plug in a 2, we get a 4. Okay? So we remember our ordered pairs. Our ordered pairs are x. Oh, hang on, let's make that blue. Our ordered pairs are x and y. Okay? Our ordered pairs are x and y, and our mapping diagram is representing the same thing, except instead of x, we're calling it our input, and instead of y, we're calling it our output. Alright, so now let's move on to example 1. Example 1 wants us to list ordered pairs of a relation. So, we're going to list the ordered pairs from the mapping diagram given to us. So let's start it off with the first one, with A. Well, our first ordered pair is going to be 1, 3. Our second ordered pair is going to be 2, 6. Our third ordered pair is going to be 3, 9. And our last ordered pair is going to be 4, 12. Alright, let's try this one over here. Oh, we have 0. Oh, let's see. 0, 0. Because 0 goes to 0. Uh-oh, what's this? We have 2 goes to 1 and 2 goes to -2. So we'll write it as this. 2, 1. 2, -2, and then here we have 4 goes to -3. 4 goes to -3. And that's all example 1 is. Just wants us to write our mapping diagrams as ordered pairs. We just need to know that the input would be x and our output would be y. Alright, moving on to example 2. Start this off, we have a very important point. I'm going to star this. A relation that pairs each input with exactly one output is called a function. Alright? A relation that pairs each input with exactly one output is a function. Alright, so I want you to think of this like a vending machine. Okay? If I walk up to a vending machine, I put my dollar in, and I press B4. Alright, B4 should give me Doritos. Okay? So if I put my money in, I press B4, the Doritos come out. That's a function. If I put my money in, press B4, and say Sun Chips come out when I wanted Doritos, that's not a function because each input does not have exactly one output. Okay? So let's try it out. Each input has to have exactly one output. So determine whether each relation is a function. Well, -9 goes to 0, -2 goes to 5, 5 goes to 10, and 12 goes to 10. So this is a function. It's okay if two inputs have the same output, it just can't be the other way around. One input can't have two outputs. The input must have an output. Now let's take a look at this one over here for B. -2 goes to 4, -1 goes to 3. All right, we're off to a good start. And 0 goes to 5, and 0 goes to 6. Since this input has two outputs, the whole relation is not a function. If one input has two outputs, it is not a function. All right, last but not least, example 3 in chapter 6.1 wants us to describe a mapping diagram. So for the first one, let's consider the mapping diagram at the left, right over here. So we want to know if it's a function or not. Well, 1 goes to 15, 2 goes to 30, 3 goes to 45, and 4 goes to 60. Each input has exactly one output. So is this a function? Yes, it is a function because each input goes to one output. 2 goes to 30, 3 goes to 45, and so on. Now, B wants us to describe the pattern of inputs. Wants us to describe the pattern of inputs and outputs in the mapping diagram. So this may look familiar to you. We want to see how much does it increase each time on the input? Well, 1 to 2, that's plus 1. 2 to 3, that's plus 1. 3 to 4, plus 1. All right, now let's look at the outputs. 15 to 30, that is plus 15. 30 to 45 is plus 15. And 45 to 60 is plus 15. All right, sorry that got a little messy there, but you see where we're going with this. This should all look really familiar. So we could say for this one, as each input increases by 1, the output increases by 15. So let's write that. As each input increases by 1, the output increases by 15. And that's all we got to explain in these examples. This should be very familiar. We're very used to using all of this from linear equations, and you probably saw this last year in 7th grade. All right. All right, and that's all we have for Chapter 6.1, Relations and Functions. Just a nice little intro. Don't forget to like and subscribe. Comment below if you have any questions. If you have any questions, we'll also be going over this in class tomorrow, so make sure you bring your questions with you. All right, have a great night.